Yeah. So on Monday we talked about our slope, which is the steepness of a line. So let's just add that in here. The slope is the steepness of a line. We discussed how many different types of slopes there are. And remember, there are 4 types of slopes. One type is going up from left to right, which is your positive slope. Another type is going down from left to right, which is your negative slope. One type is just a vertical line, which is called an undefined slope. And the other type is your horizontal line, which is called your zero slope. We also discussed how our slope is represented by a lowercase m. Remember, it is our rise over run. It is our change in y over change in x. Remember, for your y-axis, for your rise, you either go up or you go down. I'm not going to be able to fit that all in there. You either go up or down on your y. If you go up, it's a positive number. If you go down, it's a negative number. For your x-axis, your run, that's either left or right. If you go left, it's a negative number. If you go right, it's a positive number. So all that is a reminder as to what slope is. We also did learn the formula when we're given 2 points. This top part, the rise over run, up, down, positive, negative, left, right, positive, negative, that's usually when you're looking at a graph. When you're given 2 points, you most certainly could graph it and do rise over run, or you could use the slope formula. And we talked about that Monday. That is your y2 minus y1, the difference in your rise or your y values, over x2 minus x1, which is the difference in your x or your run values. Okay? So we looked at a graph, we looked at a set of ordered pairs and finding the slope from both of them. We are now quickly going to look at if we are given a table, how we find our slope. Okay? So to find the slope from the table, it's similar to using 2 points. Remember, you're worried about your change in y. That's your triangle, your delta, your change. That means the same thing over change in x. So remember, my x-axis is first on a table, my y-axis is second. So how am I going from 2 to 4? What am I doing? Am I adding or subtracting? I'm adding 2. 4 to 6, I'm adding 2. 6 to 8, I'm adding 2. 8 to 10, I'm adding 2. I am constantly adding the same number on my x-axis. Let's check my y. To go from 7 to 9, I'm adding 2. To go from 9 to 3, I'm adding 2. To go from 11 to 13, I'm adding 2. Oops, I said 9 to 3. I don't know why I said that. I meant 9 to 11, I add 2. 11 to 13, I add 2. And 13 to 15, I add 2. Again, I'm consistently adding the same number on my y. So to find my slope, I do the change in y. How much is it changing in y every time? It's changing 2 every time. Divided by my change in x. How much is it changing on the x-axis every time? And 2 divided by 2 equals 1. So my slope is 1. All right, this is asking me to find my rate of change. Rate of change, remember, is the same thing as your slope, which we use as a lowercase m. That's your change in y divided by your change in x. So let's look as we go. What's it changing on the y-axis? To go from -3 to -1, it's adding 2. To go from -1 to +1, it's adding 2. go from 1 to 3, it's adding 2, and from 3 to 5, it's adding 2. So I'm adding 2 every time on the y-axis. That's my change in y. What about the x? I'm going from -2 to -1. That's adding 1. I'm going from 1 to 0. That's adding 1. 0 to +1, that's adding 1. And 1 to 2, it's adding 1. So my, oops, I don't know why I wrote a 2. I said 1. Let me erase that so I don't make a boo-boo here. Alright, so to go from 1 to 2, it's adding 1 again. So it's doing the same thing. It's constant, adding the same number every time on my x-axis. So I put +1, and 2 divided by 1 equals 2. So my slope, or my rate of change, is 2. You can leave it as 2 over 1, or you can put it as 2. Either way is fine. Alright, change in y over change in x. That is your slope, or your rate of change. So you should recognize that. How much is it changing on the x-axis? Or sorry, the y-axis first. From 6 to 4, I am subtracting 2. From 4 to 2, I'm subtracting 2. From 2 to 0, I'm subtracting 2. From 0 to 2, I'm subtracting 2. So this is consistently decreasing by the same number every time. So the change in y, it's subtracting 2 every time. From -4 to 0, I'm adding 4. From 0 to 4, I'm adding 4. From 4 to 8, I'm adding 4. And from 8 to 12, I'm adding 4. So my change in y is +4. Remember, your slope needs to be reduced. It's written in fraction form. Reduce it if you can. On this first one, I could reduce 2 over 1 to just 2. Either way would have been accepted. This actually can be reduced to -1/2. So my slope is -1/2. Do not change that to a decimal. I use it as a fraction in the simplest form. Alright, let's check a couple more. So find my slope here. Change in y over change in x. Okay? What's the difference in my y and the difference in my x? Well, what's it doing on the y-axis? To go from 2 to 2, it's not doing anything. To go from 2 to 2, it's doing nothing. Doing nothing, doing nothing. So the change in y, there isn't a change in y. From 6 to 3, it's subtracting 3. From 3 to 0, it's subtracting 3. From 0 to -3, it's subtracting 3. And from -3 to -6, it's subtracting 3. 0 divided by -3 is 0. So my slope is 0 here. Remember, a 0 slope is a vertical line. I'm lying to you. I don't know why I said vertical line. A 0 slope is a horizontal line. I'm not even thinking right now. It's a horizontal line. Okay, that's when you have no change in your y. Your y is not doing anything. Alright, my slope for number 11. From -3 to +3, I am adding 6. Remember, change in y over change in x. That's why I'm checking the y first. 3 to 9, I'm adding 6. 9 to 21. I'm adding a lot more than 6 there. What am I adding? Looks to me like I'm adding 12. And from 21 to 33, I'm adding 12. Okay, well that's not doing the same thing every time, but let's check the x. From -2 to 0, I'm adding 2. From 0 to 2, I'm adding 2. From 2 to 6, that's not adding 2. That looks to me like it's adding 4. And from 6 to 10, I'm adding 4. So notice, it's not consistent every time. So I'm going to check each one separately. What is the very first change in y over change in x? 6 divided by 2 equals 3. What's the second change in y over change in x? 6 divided by 2 equals 3. So far, the slope is the same for them. Let's check the next one. The next change in y over change in x. 12 divided by 4 equals 3. Well, look, I got the same slope. Even though they weren't the same number, it still worked out. The second, or the last change in y over change in x is 12 divided by 4, which again equals 3. So sometimes they can be adding different numbers, But it can still work out if I check every change in y over change in x. It all turned out to 3. So my slope is the same. So be very cautious of that. All right, let's look over here. What we got going on here? My slope, my m, my change in y over change in x, my rise over run. All that stuff means the same thing. So let's check the y column. From 6 to 4, I'm subtracting 2. From 4 to 2, I'm subtracting 2. 2 to 0, I'm subtracting 2. 0 to negative 2, I'm subtracting 2. So I'm consistently doing the same thing there. Now let's check the change in y. From 3 to 3, I'm not doing anything. 3 to 3, nothing. 3 to 3, nothing. 3 to 3, nothing. If I have a 0 in the denominator, when it's not changing on your y-axis, and there's a 0 in the denominator, that is called undefined. So when it's undefined, remember, so your slope is undefined here, remember, that is a vertical line. A vertical line is not going left or right at all. It's only going up or down. So if it's not going left or right, it's not changing at all on the x-axis. But it certainly is going up or down, so it's changing on the y. That is an undefined slope. All right, here's number 13 a try. So my m, my rise over run, my change in y over change in x. To go from 4 to... Alright, so change in y. 4 to 3, I am subtracting 1. 3 to 2, I'm subtracting 1. 2 to 1, I'm subtracting 1. 1 to 0, I am also subtracting 1. So I'm doing the same thing every time on the y. So minus 1 goes for your rise. For my run, I'm going from negative 4 to negative 1. Looks to me like I'm adding 3. From negative 1 to positive 2, I'm adding 3. From positive 2 to positive 5, I'm adding 3. From positive 5 to positive 8, I'm adding 3. So I'm doing the same thing every time here. So my change in y is adding 3. So my slope is negative 1/3. I cannot reduce that at all. Which table has a rate of change equal to 4? Remember, your rate of change is your slope, or your m, or your rise over run, or your change in y over change in x. Which one has a slope of 4? So let's check. Negative 12 to 4. What am I adding there? I'm sorry, negative 12 to negative 4. Looks like I'm increasing by 8. Negative 4 to 8. Looks like I'm increasing by 12. 8 to 20. Looks like I'm increasing by 12. All right, check my x. Negative 3 to negative 1. Looks like I'm increasing by 2. Negative 1 to 2. Looks like I'm increasing by 3. And 2 to 5. Looks like I'm increasing by 3. So notice, I'm not doing the same thing every time on my y or every time on my x. So I have to check every one separately. So I have to check every change in y over change in x separately. So the first change in y is 8. The first change in x is 2. And that simplifies to 4. The second change in y is 12. Divided by the second change in x is 3. And that also reduces to 4. The third change in y is 12. The third change in x is 3, and that also reduces to 4. So it looks like this one is it. I'm always hesitant, though, when the first one is it. So I'm going to go check the rest. So, all right, so to go from 10.4 to 0.8, obviously I'm subtracting something. I'm subtracting 9.6. To go from 0.8 to negative 2.4, I am subtracting 3.2. And to go from negative 2.4 to negative 8.8, I am subtracting 6.4. On my x's, negative 4 to 2, it looks like I'm adding 6. 2 to 4, I'm adding 2. And 4 to 8, I'm adding 4. So I'm doing something different every time. So I have to check every single change in y over change in x. So negative 9.6 divided by 6, does that reduce at all? Check yourself on your calculator. That reduces to negative 8 over 5, which clearly is not 4. So do I even care to check the rest? No. Okay. Check those last two, and you can make sure that they're not. So 6.5 to 2.7. Obviously, I'm subtracting something. I'm subtracting 3.75. 2.75 to 1.5. I'm subtracting 1.25. And 1.5 to negative 1. I'm subtracting 2.5. So my change in y is all different. My change in x, negative 4 to 2. I'm adding 6. 2 to 4. I'm adding 6. 4 to 8. I'm adding 4. So check every change in y over change in x. So negative 3.75 divided by 6 is negative, negative 5 over 8. That's not the same as 4, so cross that one off. Very last one, let's prove why it's not that. 12 to 4, I'm subtracting 8. 4 to negative 8, I'm subtracting 12. And negative 8 to negative 20, I'm subtracting 12. On my x, negative 3 to negative 2, I'm adding 2. Sorry, negative 3 to negative 1, I'm adding 2. Negative 1 to 2, looks like I'm adding 3. And 2 to 5, looks like I'm adding, what am I adding there? 3? Alright, so now, check my change in y over change in x. They're all different, so check every one. Negative 8 divided by 2 is negative 4. I wanted the slope to, or the rate of change to be a positive 4, so that one's out of there. I don't even need to check the rest. Alright, make sure you check your little class and see what you need to do next.